Hello, networkers, and welcome back to another episode of Ask the Network Engineer. And this time, this question comes from Christian, and he asks, as a network engineer, how much do we need to know about cabling? That's a great question, so let's talk about that now. When it comes to cabling, it's really more important to kind of learn the concepts and the components involved, not necessarily master or to really do yourself. In today's data center and most wiring closets, there are dedicated people that do that today. In data centers, there are like data center technicians or facility folks, that takes care of power, cooling, and basically the cabling. There's also cabling contractors. They're trained for doing that kind of stuff. Now that's probably more for medium and large size environments. For smaller SMB, yes, you may contract a cabling contractor to do the wiring between the different cubicles or the user locations back to the wiring closet. So that will still be there. But you may do some more of the patching between the patch panels and to the switches. And if you see most wiring closets, it's probably not the most sophisticated setup. It can be very, very messy. You have to train for that kind of thing. And typically, that's not what network engineers really do. So really though, there is network engineers, there's network technicians, and there is the facilities people or data center type folks. And when I say a network engineer, which is really the focus in this channel, that's a person that does the operational stuff, right? The configuration, the support, and may also do some design and architecture type work. That's what they do. Network technicians, these are the ones that would typically do the racking and the stacking of the equipment, maybe the servers, even do some cabling between the patch panels and things like that. That's what they typically do. There are the facility folks, or again, data center technicians, depends how you want, depending on the job title. And they would typically do all the power runs and get the power requirements. They do all the cabling, the wiring across the railways. They do all the cooling, the hot, the cool aisles. They take care of all those particular details. And that's very, very common. I mean, for example, for the CCIE, for the data center track, they don't ask you questions about how do you do cabling, how do you do cooling. Those aren't questions that is emphasized. It's emphasized on operational and design. Okay, so that's why, again, don't master, but at least be aware of some of the data center components, even the cabling that may be required. And let's get into that. Let's talk about cabling. So really, when it comes to what to know about it, well, we know that there are two types of cabling options, right? There's copper or unshielded twisted pair, UTP. And there is fiber. Now there's coaxial, but that's something more legacy with older tin-based technologies a long time ago. Today's technologies are using either copper or fiber for connecting between different buildings, between different networking equipment. So when we talk about copper or basically UTP, know about the different categories. Know about the distances that are supported with those category cables. And so, for example, like categories 1 through 5, that's really typical or aimed for fast Ethernet and can support up to 100 meters. Category 5E and category 6, that's really for gigabit Ethernet, also up to 100 meters. You got, let's say, category 6A, which is for 10 gig, but it has a shorter distance requirement. It can only support up to 55 meters. But there's category 7, which also supports 10 gigabit Ethernet, but that supports up to 100 meters. So really, what's the difference between a category 6A and a category 7? Well, the difference is because of the frequency bandwidth. That's something that you have to kind of be aware of really what makes the difference between the different categories. We can even be more ambitious. There's even category 8, which is for 40 gigabit Ethernet, but that has a much shorter distance, which makes sense, which is up to 30 meters. So again, understanding that is important as a network engineer. Well, what about distances that are a lot further than just 100 meters, the very typical that you expect within a building, for example, or within basically a floor? Well, that's where fiber comes in. So when you need to learn about fiber, Just understand that there are two types of fiber, right? There is basically single mode fiber and there is multi-mode fiber. So multi-mode means that it can support basically shorter distances. And for single mode, it can support longer distances. So how short and long are we talking about compared to UTP? Well, it all depends, but really for multi-mode, it can really support between 500 meters up to 2,000 meters. That's basically like 1.24 miles, if I do my conversions correctly. And that's typically used when you want to wire things within the same building, right? Let's say that you have a particular building with a couple of floors. You may have a distribution switch, and you have multi-mode fiber being run from the data center or the MDF down to each of the IDF or the wiring closets to access switches. That's very typical. That is in the realm of multi-mode fiber. Single mode has a lot longer distance. That's between 2,000 to about 10,000 meters, and that's about 6 miles. But it can even go beyond that as well with a lot of extended basically long range, up to 40,000 meters. And that's roughly about 25 miles. So you can kind of get the idea of how that can be used. Where for single mode, that's more for connecting between different buildings. So imagine this kind of scenario and why it's important as a network engineer if you're dealing with large scale type of deployments. So imagine that you have this big campus, right? Whether it's a university, a government network, that sort of thing. Well, those different buildings will likely have their own distribution switch. And then from there, that distribution switch will have its own multi-mode fiber connecting to different parts of that building, different wiring closets, feeding other access switches. Then all of the different buildings will have single mode fiber, very likely, connecting back to some central location, maybe a data center or some other building. And basically that connects into a core switch. So really, those are very, very important aspects for why you need to know that. You need to know about basically what is the distance between the different locations and the equipment that will exist. You can make your requirements of saying, okay, we will need this kind of fiber or maybe copper wiring to meet these requirements of the design that we put forth and what we want to configure. So again, as you can tell, very, very important. But very quickly before I conclude, with fiber, it's not just single mode and multi-mode. You also have to understand the different optics or the fiber modules. Very, very, very important. So what am I talking about exactly? So usually with most deployments with Fast Ethernet and GigE, we're talking about RJ45 ports, right? Every switch basically has that. It's very cheap and affordable to do all that, right? Plug it in, but that's more for UTP. What about for fiber? Well, for Fast Ethernet, they did have basically something called pretty much an MTRJ. I remember working with this at the Department of Energy. There's a lot of older legacy equipment. Basically, we had fiber, we had multi-mode fiber, but it was MTRJ, and that was a lot of fun. Anyway, so then there's gigabit Ethernet. So some of those fiber module options is basically the very first one was called GBIC. That's what we called it. And it was a lot bigger, and that basically meant that it was a lower port requirements that we could do with our equipment. Like the Cisco Catalyst switches, we could probably do like maybe 8, gig ports to a particular line module. And basically, I think there's also an 8, I think there's like a 16 port, but you're very, very limited to what you could do. But you get these little GBIC modules, you pop into a slot based on the particular line modules or the particular router or switch that you're using. And there it is. You put your single mode or your multi-mode fiber into it. Well, that later evolved to having an SFP, which is basically a shorter form kind of module that can allow more higher port density for 1 gig connections. Now, when we talk about 10 gig, there are a lot of different type of fiber modules available. The most popular one is an SFP Plus. Those are ones I use a lot. But there's other ones, probably more for the legacy, like a lot of, not too old. I mean, because 10 gig has been around for a long time. But there are different type of modules too, though, that can be used. There's some called an XIMPACT, there's X2s, there's some called an XFP. Wonderful acronyms, but just something you can kind of keep in mind. And then there's 40 gig. 40 gig has something called a QSFP plus. And then for 100 gig, there's also different kind of modules available for that, which is a CFP, a CXP, and a CPAC. I'm surprised I even remember a lot of this stuff here. But these are things that as a network engineer, you should be aware of these kind of things. What kind of modules actually exist? And what are my cabling options for copper or for fiber? What are the distances that are required? So you can tell knowing this is important as a network engineer, just not necessarily you doing it yourself. And we're done with this episode. So if you have any questions about being a network engineer or anything in the networking field, please post those questions below in the comments and your question will come up in a future episode on this channel. So thank you for watching this video. Please like, share, subscribe, and support us at routhub.net. And until next time, keep networking.